Hi there. This tutorial will help you get through the motion graph analysis worksheet. This is specifically for people in Bells 2 and 3 this year. With testing this week, the flow kind of got messed up. So this is for Bells 2 and 3 only. If you're in Bells 5 and 7 and you're watching this video, it might not make sense to you because we did something different. So for starters, the warm-up says to highlight and copy the questions in table 1, and this is table 1 right here, everything in this table. So this is what I'm going to copy. Highlight and copy the questions in table 1. All right, so I'm going to copy this table right here, and then I'm going to click on this link. What this link does is this opens up a new Google Sheet, which helps you do some calculations we're going to do. We're going to paste it into the table, and then we're going to explore the functions over here and make a graph, and then paste the graph below. So first, should look like this once you got it open. And then once you paste it, it should look like that. All right. So one more time, select everything in this table, copy it, paste it here. And again, I'm here from clicking on this first link in here to open up a new Google Sheet. All right. Then what we're going to do is we're going to do two things. I'm going to show you how to do calculations and how to make a graph. So the first thing we're going to do is we want to do our calculations for speed. And we've learned that the calculation for speed is distance divided by time. So we're going to want to divide the number that is in our distance box divided by the number that's in our time box. So here is your distance right there. Here is your time right there. So that's what we want to divide. So what I'm going to do is I'm going to click on here, and you can get Google Sheets to do math for you by clicking the equals button. All right, so in this box, I'm going to start by typing in, hitting the equals key. And you should see some things change already, and that's what you're looking for. So you want to do distance. So you're going to click on the box that has the number 4 in it. That is our distance. So I'm going to click on this one first. And then division is slash. So I'm going to do a slash. And then I'm going to do time and click this box. So your boxes should be a letter and a number in orange, slash, and a letter and number in purple. And that's how you do it. Okay, so one more time. Oops, I got stuck in a loop here. Zoom in a little bit so you can see better. So I'm going to click on here. I'm going to hit equals. I'm going to click on the distance box. I'm going to hit slash for divide, and then I'm going to click on the number 1. Click on these numbers. Do not type them in. Otherwise, what I'm going to do next will not work. All right, I'm going to hit enter, which will tell the computer you're confirming this math equation. You might see it do a suggested autofill, but I want to show you how to do it for real because sometimes that autofill doesn't do what we want it to. So distance divided by time would give you 4 meters per second. And that's exactly what you're looking for. So if you want to continue this function all the way down, you click on this box again, and you should see a little blue square right there in the corner. You're going to click on that, and you're going to drag it down. And you're going to go all the way down until 10. And you can see that it's going to automatically calculate those things for you. All right, and that's what it's doing. If you click on any one of these, it'll show you that it's doing, all right, I'm going to divide this by this, this by this, and it continues that trend. That saves you so much time. So I'm going to do it one more time for you guys. Remember the blue little square in the bottom right corner, click and drag it all the way down till the last box and let go. And this will auto-calculate the speed at every second for you. Now, if you want to clean it up a little bit so you don't have these crazy numbers in here, you can use these buttons up here. And I'm going to decrease the indent and then increase it twice. All right, so I'm going to use these buttons up here to make the rounding a little bit neater. All right, then I'm going to copy this and I'm going to go back to my document and I'm going to paste it right here. And that will put all the stuff I want in the chart for me. So now that I've calculated the speed, we're going to go back and we're going to look at a chart. And we're going to do the chart of the distance and time. So what you want to do is you want to highlight the time box and the distance box and then drag all the way down so you select everything in the time and distance. We're not going to touch speed right now. In the bottom right corner, you should see a button that says Explore. Click on that, and then it'll auto-generate some graphs for you. And you want the one that looks like this, where it's distance versus time, where distance is on the y-axis and y is on the x-axis. I'm sorry, time is on the x-axis. You're going to click the Insert button, and then you can drag the chart over. And then now you have a graph of all this information. And you guys don't really realize how lucky you are that it's that easy. It used to be a lot harder than that. So one more time. Okay, I'm going to select the columns that I want to make the graph of. I'm going to click on the Explore button in the bottom corner. And then I'm going to scroll down until I see this one right here. For the y-axis being distance and the x-axis being time, I'm going to click this button and then it'll submit it in there. All right. Then you're going to click on this chart, Control C, copy, come back, and then in here, you want to paste it up here above the chart. All right. And you can either link it or not link it. It doesn't matter. And then you might want to resize it so it doesn't take up so much space. And then there you go. That's how you do it. So now you have a chart and you have your graph. And this is what I'm looking for. So what you're wanting to check out here, what I want you to do in the next couple questions is, how does the distance changing affect the time, and what does it do to the speed? So the first question is, what does the graph tell you about the motion of the sprinter? All right, so where it has the steepest slope means it's going the fastest. Right? And if you look, it kind of starts shallow and then it keeps going up with a very steep incline. These all look kind of like they're on the same line. So that means the sprinter is increasing his speed constantly over time. It's the same speed at each time. So when you look at the graph down here too, you see that matches up. He's going his fastest speeds towards the end. And that kind of makes sense because if you're running a race and it's close, you are trying to run your fastest right there at the end so you could pass the person next to you and win. So that does make sense. So you can say something along the lines of the slope is increasing as time goes on. So that means he's getting faster and faster. His fastest time is at the end because he's trying to win the race. And then at which distance time is it running the fastest, then you can use this right here. So he's running the fastest when he crosses the 100-meter finish line, and he's going at a speed of 9.71 meters per second. So the key about this is what we did here in this speed column. This is going to come back for us, and it's going to make your life a lot easier next week and in the future. Okay, so that's how we do the warm-up. If you need help on that, rewind, go back, and watch this again. Make sure that you don't skip on this part. Next, we're going to move on to the motion graph here. Okay, so this is my motion graph, and it's going to help us talk about questions 1 through 8. So I'm going to stay focused up here on the graph, and I'm going to draw on the screen a little bit, and I'm going to mention the questions down below. They should help you then figure out what to type and what to do. All right, so let's get started with this. So we have a slope that starts out with a gentle increase, and then you got a flat line up at the top, and then it picks up again. So this represents somebody running a race, all right, or an object moving. So we have the distance on our y-axis and the time on our x-axis. As the time goes by, you can see that his distance spikes up, flattens out, and goes up again. There are letter intervals at every 5 seconds. So you have, a B here, C, D, E, and F. All right, A is at the beginning, and they all correspond with each 5 second mark below. 5 seconds, 10 seconds. This line slid over on accident, so just call this 15, 20, 25 towards the end. So that's where they all line up. So each dotted line represents a different segment on the graph. So first question says, between which two letters is the rate of the speed the fastest? So the speed on a graph is determined by the slope of the line. So wherever the slope is the steepest, that means it covers the most distance in the shortest amount of time. All right, so think of it like a hill. Wherever there is a steep hill, this guy is moving fast. So when you look over here, you can see that you got a few sections to look at. You got, let's go with here, you have something going on. Here you have another one. Here it curves. Here it stays flat. And then here it pokes up again. So at each one of these sections, which one has the steepest slope? All right, and if you think about it and look at it, you can see that between the points of B and C, the slope is the steepest. The line is the closest to being vertical, and that's what this slope is. So number one is between B and C because he covers the most ground in the 5 second interval. So he's got 5 seconds here, and between B, he starts at 20, and then C, he's at 50. So he covers 30 meters in 5 seconds, and that's the most ground covered between any 2 points. So that's why that's the answer. The least amount of distance covered between two letters is between D and E, because from spot D, he's at about here on the x-axis or the y-axis, which let's call that 52. And he's at the same spot at point E. So he's also at 52. So if over 5 seconds your distance doesn't change, you're obviously standing still. So that's why the least amount of distance is covered there. All right, next, we're going to look at the type of motion occurring between C and D. So C is right here, and D is right here. So he's covering less and less ground over time. All right, so he's starting steep between B and C. So in order to answer this one, you can talk about this a few ways. One, look at what's happening before it and after it. So before C, he was moving the fastest. Remember? So we said in question 1 that this was the fastest point. And then in question 2, we were talking about he's covering the least distance here. So he is going slow here. So if you're going from fast to slow, you are slowing down. Does that make sense? If you're running and then you have to come to stop to slow down, you are slowing down. So in general, when we look at these graphs, if the graph makes an upside down arc, like it goes like this, that means something is slowing down. If something makes an arc where it's moving up like this, that means it's speeding up. And another way I like to remember this is if your graph for speed makes a frown, it's slowing down. You can thank me for that one later. So that is what is happening between C and D, is you have some slowdown. And then the evidence for that is that you could talk about how it was going fast before, and then it comes to a stop. So it's slow. Therefore, when you do that, it goes from fast to slow down. All right. So during the total journey, how many seconds did the object pass where it's not in motion? So remember, we talked about this section again being where he's not moving. Okay. If he stopped moving at 14 seconds and then he picks up again at 19 seconds, you can see his slope increases this way. So that means he's moving again. You can do the math there. 19 minus 14 to figure out how many seconds he was not moving. So now we want to calculate the speed between B and C where he was moving the fastest. So we have B here and C here. What is the speed he's going between this distance here? So in this section, how fast is he going? So if we remember, speed is equal to the distance divided by the time it took. So the distance he traveled is, sorry about that, is between, he starts at B, which is 20, ends at C, which is at 50 meters. So if he is at 5 seconds into the race, he is at 20 meters, and then at 10 seconds, he is at 50 meters. The distance between these two is 30. So you're going to have 30 meters as your distance divided by the time it took. So if he started at 5 seconds and then where the end of this time zone is at 10 seconds, this time interval is 5 seconds. So you divide it by 5 seconds. Meters, seconds, and then your answer is the answer to number 5. So that is how you read between those two. Number 6 is how much distance did he cover over the entire journey? So let's go erase this. So over the entire journey, he ended here. All right, so at F is where he ended. So at 25 seconds, let's call that 60. Even though it goes above a little bit, like I mentioned before, it kind of, the graph shifted when I made this assignment, and I can't shift it back without screwing up everything. So the total distance he traveled is 60. So we're going to need that when we calculate the speed, his average speed over the entire journey. So his average speed over the entire journey between points A and F. So remember, if A is down here at the beginning and F is up here. All right, and we had just mentioned that the distance he covered is 60 meters. We're going to need the time it took to get the speed. So the total time he spent was 24. So 60 divided by 24 will give you the total speed of this race. And it's the average speed. So you would get the same answer if you calculated the speed at every second and then took the average of those seconds, you'd get this answer too. So 60 divided by 24 will give you the speed on average for this entire journey. So finally, looking at number 8, when you look at this, it says the graph represents someone going uphill, true or false. I've mentioned this before in class, but if you didn't catch it, these graphs have nothing to do with the terrain he's running on. So remember, we said he was going fast here, okay? And slow here because he stopped. So if he stops here, he's not moving very fast. And it does not represent a hill. If you've ever tried to run up a hill in your life, when you run uphill, your speed goes down because you have to work harder against gravity to get up the hill. So a lot of times students get confused and stuck because they think that because this looks like he's running uphill and then flat and then up again, it means that he's running uphill, and that's not true. If you read through your graph and you think about it, if you talk yourself through it, he starts at 0, his speed increases, he covers more distance, he stops moving, and then at E, he picks up his speed again and starts to move again. So this could be the opposite. He could be running downhill, get to the bottom, and he's tired, and then he's walking on flat ground. He could be riding a bike. He could be flying in an airplane. He could be in a boat. The graph does not say anything about the terrain at all. Okay. So lastly, this is kind of like the homework question. Looking at these here, you have 3 runners, and Albert, Bob, and Charlie. They're running a 100-meter race, which you can see right here up at the top where it says 100. And the time goes up to 18 seconds. And you can see that there are 3 different paths here. All right, so let's see if I can draw this out. Albert is this red path here. Again, sorry about the lines. Charlie will be this blue one. And then Bob will be this green one. So, Bob, Charlie, and Albert. All right, so a couple questions. 1, which one won the race? Think about it. When you sprint and you're running a race that's 100 meters, that's one length of the track, who wins? The guy that gets there first. Whoever gets there first gets there in the shortest amount of time. So which one of these 3 had the shortest amount of time here at the bottom? All right, so Albert would come down here. Bob would come down here. And Charlie would come down right here. So who did it the fastest? Who stopped? Remember, up above, we talked about how if you stop, the chart goes flat. Which one of these runners has a flat spot in their line? And how long did they stop for? So you check where the flat line started and about where it ended, and then give me an estimate on the time it took. Then you can calculate each one's speed by dividing the distance by the time it took. All right, so for example, if I wanted to do Albert did 100 meters, and they all did 100, so you're going to use 100 for every one of your distances, divided by the time it took. Albert finished his race in 12 seconds. 12. This answer is what goes in the yellow box. You're going to do the same for Bob, and you do the same for Charlie, and write down their speeds. Their speeds should match the ones that won the race. So whoever won the race should have the highest speed. So you can go back and double check your answer for number 1 there. All right. Hopefully that helps out with this. I understand that we had some class time run short when we did it, but this video should help out. If you have any questions, please reach out to me and I can help you with this more. This is due by the end of the week, so please don't hesitate to get it done. Hope this helps, and I will see you guys in class.